Hello, in this video I will decompose a partial fraction with a repeating linear um, factor. So the direction says decompose into partial fraction where we have 6x squared minus 14x minus 27 all over x plus 2 parentheses x plus 2 parentheses x minus 3 squared. So we have a repeating linear factor. So uh, the x plus 2 is a linear factor, but it's not repeating. The x minus 3 is the repeated linear factor. Okay, so the x minus 3 basically means you can write it out as x minus 3 times x minus 3 twice, right? So you're going to set it up as a over x plus 2, and then b is going to be, so x minus 3 squared is the same thing as x minus 3 times x minus 3. So your b is going to be x minus 3. And then your c, yes, we have a c, is going to be x minus 3 squared. Now, okay, so look at our degree. So is our degree on the bottom bigger than on the top? You always got to check for that. So on this part, yes, this has a degree of 1. This a actually does have a degree, it's x to the 0, right? When you have a constant, it does have an invisible power of 0. What about b? Is the degree on the bottom bigger on the top? Yes, this has a power of 1, this has x to the 0. Now, what about c? You have this power 2, but here's the thing. You only care about the power inside the parentheses. So our power inside the parentheses is 1. So this is a power to the 0. So yes, it checks out. So they all check out as the degree on the bottom is bigger than the top. Okay, so now what we have to do is find our a, b, and c by getting rid of the fraction. So let me rewrite the problem again so you don't get confused. Okay, so we could get rid of the fraction by multiplying all 1, 2, 3, 4 sides by the LCD. So what do you think our LCD is? It's going to be x plus 2, x minus 3 squared. If you forget how to find the LCD, there is a video on my playlist that talks about LCD. So I'm going to multiply all 1, 2, 3, all 4 sides by that. Okay, so on the left side, what do you see that cancels the x plus 2 and the x minus 3 square? So you're left with 6x squared. And then on the right, so if you multiply this by here, what do you see that cancels? Or what do you see that's same on the top and bottom? The x plus 2. So the x plus 2 cancels, so you're left with a, and then x minus 3 squared. Plus, what about here? What do you see that cancels? The x minus 3, but this is to the power of 1. So it's going to be, you're still left with the b, and then you're still left with the x plus 2, and then you're still left with the x minus 3. Now on the right, what do you see that on this part right here? What do you see that's same top and bottom? The x minus 3 squared, so you're left with c and x plus 2. Okay. Okay, and then your goal is to solve for a and b and c. How do we solve it? By plugging in you can plug in an x value. So the x value I'm going to use for right now, I'm going to use let x equals 3, positive 3. So I'm going to put 3 where we see x plug in 3. So it's going to be 6 times 3 squared. And then this is a, and then 3 minus 3 squared plus b 3 plus 2. 3 minus 3, it doesn't really matter because this will cancel. And then 3 plus 2. So on the left side right here, when you put it all together, you should get an output of negative 15. On the right, 3 minus 3 is just 0, so that's just 0. 3 minus 3 is just 0, so that's 0. And then this would be 3 plus 2 is 5, times by c, that's 5c. So on the right, that's 5c plus negative 15. Divide this by 5, I get c equals to negative 15 divided by 5 is negative 3. Okay, so I have my c value. I still got to find my b and my a, my c, right? So I should use another x value, and this time I'm going to use x equals negative 2. So go back to this equation, this stuff right here. Plug in x for negative 2, and then you have a c value. Then you have you can plug in c value for negative 3, right? So go back to here and plug in x equals negative 2. So it's going to be 6 negative 2 squared we do not know what our a value is, so I'm going to leave it as a, and it's going to be negative 2 minus 3 squared plus b, and then this is going to be negative 2 plus 2, negative 2 minus 3, and then this is going to be negative 2 plus 2. Okay, so this is going to be, when you put it all together, you should get 25. Over here, this is going to be a negative 2 minus 3 is negative 5 squared. Over here, the negative 2 plus 2, that becomes 0. 0 times anything is just 0. The same thing here. Negative 2 plus 2 is 0 times by c, that's just 0 as well. Okay. Negative 5 squared is 25. A, and then over here you have 25. Solve for a by dividing both sides by 25, you get a equals 1. Okay, so my a value is 1, my c value is negative 3. The next thing I got to do is find my b. For this time, I'm going to let x equal 4. Okay. And then you're going to put it back here. And then you also can plug in your c value and your a value, right? So I'm going to say x equals to positive 4. Okay, so it's going to be here. Maybe I should write the problem again. So we know that we're going to set x equals to +4, and we know that c equals to -3, and we also know that a equals to +1. Okay, so let's plug in our x value for. So a is 1, so it's 1, and then x is 4, so it's 4 minus 3 squared. X is 4 plus 2. C is -3, and then x is 4 plus 2. So this would be 13. And then this is going to be 4 minus 3 is 1 squared plus b. 4 plus 2 is 6. 4 minus 3 is 1 minus 3 times 4 plus 2 is 6. So 1 squared is 1 times it by 1 plus 6 times 1 times b, that's 6b. -3 times 6 is -18. And then this is 13. So this is going to be 6b. 1 minus 18 is -17. Add 17, add 17. 17 plus 30, 17 plus 13 is 30. Divide this by 6. You get b equals 5. Okay, so our final answer in decomposition is going to be this. So we know that our a value is 1, my b value is 5, and then my c value is 3. So when you put it all together, you get this. Okay, so it decomposes to this. And when later on in calculus 2, you can easily take the integration of each term, right? You can take the integration of this by using u substitution, the same thing with this and this, right? All by u substitution. So that is why we are learning how to do partial decomposition, because we are going to integrate. Okay, that wraps it up for this section.